Nearly every cell in your body houses your all-important genetic information. Tightly coiled in the nucleus of each cell, deoxyribonucleic acid, DNA, forms the building blocks of what makes you, you. As the blueprint for our bodies, DNA can also reveal information about our ancestry. In recent years, people have become increasingly interested in finding out more about their genetic origins. 23andMe, named after the 23 pairs of chromosomes in a normal human cell, are one of many companies heeding that call and digging into our DNA. The way 23andMe identify your genetic ancestry is mostly a game of genetic guess who. By comparing each customer's DNA variants, differences in DNA sequence, with those of people from around the world, geneticists can match and eliminate geographical locations based on the population's genes. Knowing which part of the world your ancestors came from, however, isn't the only historical information that can be extracted from your DNA. It can also provide some clues about your gene's journey to where you are now. By analyzing the mitochondrial DNA, which is inherited only from your mother, and the Y chromosome in males, geneticists can reveal the migrations of our ancestors. By looking at genetic variants and mutations, paternal and maternal lines are characterized into separate groups known as haplogroups. These tend to share similar geographical roots, and based on our current understanding of prehistoric human migrations, their footsteps can be followed across the globe from a single ancestor in Africa all the way to where you are now. Within some people's DNA, there are variants associated with our ancient human relatives. Before the Neanderthals died out around 40,000 years ago, they coexisted with Homo sapiens in parts of Eurasia, during which time the two species interbred. Remnants of those ancient relationships can be found in our genes. Research suggests the majority of Europeans and Asians have around 2% Neanderthal DNA. This information is related to physical traits such as height and hair, and by testing our DNA, scientists can estimate how many of these variants we have in common with our extinct Neanderthal cousins.